Actually, we perform a number of different tasks like creating requirements, specification, architecting the system, design code, and design test, etc. So, it will be helpful if we are conceptualizing these tasks in diagrams. So, we have actually developed unified mm, modeling language, which is shortly known as UML diagrams. Actually, UML diagram is an object oriented. As it is an object oriented specification, there are two complementary ways. That is, it allows a system to be descriptive in a way that closely model real world objects and their interactions, and also it provides a basic set of primitives that can be used to describe system with particular attributes irrespective of the relationship of those system components to the real world objects. So here there are two diagrams showing UML notation as well as a class notation. First one is the object notation and then a class representation. So first of all, let's move on to the object. In UML notation, a text in the folded corner page is a note. It serves as comment. Object is identified by the unique name and its member of a class, and it is underlined to show that it is a description of the object and not of the class. A class, actually, it is a type definition. All the objects derived from the same class have same characteristics, although their attributes may have different values. And these attributes, a class defines the attributes that the object may have, and it also defines operations that determine how the object interact with rest of the world. In this diagram, D1 is the object, since D1 is an instance of the class display. Okay, D1 helps to manipulate the objects, manipulate the defined operations. It will help to interact with its members. Okay, next is the choice of interface is very important decision in object oriented decision making, and the proper interface must provide ways to assess the object state, and we cannot directly see these attributes as well as ways to update the states, and several types of relationship that can be used that can exist between the objects and classes are association. Association occur between objects that communicate with each other but have no ownership relationship between them. Aggregation, as the name suggests, complex objects are made into small objects. Composition is a type of aggregation in which the owner does not allow the access to the component objects. Generalization allows us to define one class in terms of another. We have an example here. It is a derived class as a form of generalization in UML. Generalization symbol is shown in the figure. It's like an arrow mark which is not colored. Okay, derived class inherits all the attributes and operation from its base class. Okay, in this display is the base class, and two derived class BW display and a color map display inherits from the base class display. We have multiple inheritance. It is a form of generalization where there will be two base classes and a derived class inherits from more than one base class. That is shown in the figure below. Here there are two base class and a derived class which is multimedia display inherits from speaker base class and display base class. Okay, then we have links and association. Links actually exist because the objects does not stand alone. And association helps to characterize the type of information about these links. Okay, the link is shown here, that is message sent, they all are connected, that is the link between the objects is shown in the first figure. And then association means it can be one to one, one to many, many to many, that is we are writing some numericals on those links. So in that messages it can have many integers from 0 to n. So message which is 0 to n is sent to a particular user. So each message is sent to a particular person, that is shown in that diagram. Thank you.